In this video, I'm going to show you how you can perform a multinomial logistic regression. In this case, we're using it so that we can look at our model criteria and decide which of our binary logistic regression models are actually best. So normally, the multinomial regression would be used for when you have an outcome that's nominal, but you have more than two categories. So here we have Titanic dataset and we have a binary outcome, survived or died. But you might have a situation where you have more than two categories. For example, unsatisfied, satisfied, very satisfied. You have at least three categories. So you use the same analysis to do both. We're using it for binary outcome because we want to use some of the information criteria to help describe our model. So the first thing we do is we put our dependent variable here into this box. The reference category automatically goes last. In this case, that would be 1. This means that all of our odds ratios will be explained as in the odds of dying, because 1 would be our reference category, which would mean survived. So we're just going to swap this to first category so that our odds ratios, and when we come to interpret the table, they're based on survival. We then need to move any variables which have more than two categories into the factors box. So that would apply to passenger class and country of residence. Scale variables and also variables with just two categories can go here into the covariates. You don't need to worry about model for now unless you're including an interaction term. I will show you that at the end of the video. But you may find it useful to tick a few other options. You might be interested in the classifications table, and we are definitely interested in the goodness of fit and the information criteria. This is what we're really interested in. So we're going to click continue and then OK. Quite a few tables will appear. The first table reminds us what categories we have and how many people fell into these different categories. And then we have our model fitting criteria. There's quite a few different ways for you to look at your model. Some of the most popular ways are to use the AIC, the AIC information criteria or the Bayesian information criteria to look at how well your models fit. The first row is really the null hypothesis. So if all of your independent variables were set to 0, what is the difference when you then include these independent variables? And this is significantly different from the baseline. These are the values that you would use. These are the values that are actually for your model. So if you rerun the analysis excluding one of your variables, then you would compare the numbers to these numbers here. If you are doing a nested logistic regression, then you might want to use the deviance rather than AIC or BIC. If you get a significant difference like here, this would actually indicate perhaps not a very good fit. So ideally you want to have non-significant here. You might also want to look at the pseudo R-square. We don't have a standard R-square in a logistic regression, but there are different ways that we can look at the pseudo versions. You may have a preference. Whichever one you use, just be consistent to compare them with the different models that you create. So what these are saying is, in the case of the Nagelkerke, which is the one I'm going to base on today, what we're saying is that 46% of the variance that we observe in the outcome, which is survived or died, can be explained by the independent variables that we have included in this particular model. If we go down here, we can also see that age, gender and class are all having a significant impact on the model, but country of residence is not. And if we were to go down here, we would see a similar situation where country of residence, we do not have a significant difference here. So all these other variables appear to be significant, and this is our classification table that you might remember from the binary logistic regression video, and we have our odds ratios here. So we know, for example, this is saying that women were 12 times more likely to survive than men because of the way round that we have the reference categories. Now we might decide that we don't want to include country of residence any longer. So what we can do is we can go back to our model and we can then remove country of residence, run it again, and then what we can do is we can compare our AIC and our BIC numbers. So last time they were about 700 each, so we can see that they have reduced. You're welcome to do some research on these different techniques. They have some slightly different drawbacks. For example, they will both penalise models for having too many independent variables. So these numbers will go down automatically when you remove a variable. So you need to do a little bit of research if you're going to use these. But so far, this would suggest that we have improved the model. These values have gone down by a fair bit. This here, the percentage, we have 45.7% of explaining the variance, and if we go back to our previous, so it's only changed ever so slightly. But the main thing is here that we haven't really lost too much explanation from losing this one particular variable. And then again, you will have the repeat here of your model. Now, with the Titanic data set, we actually have a bit of a complication. Now, from making graphs, you might notice with the data that actually we have some interaction terms going on. And this becomes apparent when you actually exclude some of these variables. And if you were to, for example, if you were to put country of residence in, let's do that now. So let's put country of residence back in, but let's remove class, and I'm going to remove gender, do OK. Suddenly, country of residence is now significant where it wasn't before. But the explanation is a lot less. It's now only 6.4% of the variance being explained. So this is a bit of a confusing result. We might decide that based on the Pseudorsquare values, we're not going to be too worried about country of residence. However, we might want to investigate whether we have some interactions. In the binary logistic regression, this was straightforward, because we had a little button that would appear here whenever we held down Shift and held down two variables. But unfortunately, it's not quite as simple in our logistic regression. So if we put our variables back here, we can then go to model. And here you can see that we can actually include some interactions. So I'm going to have to click on custom, and then I'm going to click on gender, and I'm also going to click on age. And I'm just going to hold down Shift on my keyboard to move those together. So this little asterisk means that they are now an interaction. Again, I'm going to do the same with passenger class and gender and move them over. But if I leave it like this, these are the only variables, these two interactions that will be entered into my model. So I'm then going to enter each of our variables back in, and I'm going to look for main effects, and then I'm going to press continue. OK. And what we will actually see here is we have about 50% of the variance which is explained. We have our AIC and BIC are slightly better than the very first one that we included, but maybe not as good as the second one that I showed you. What's interesting though is that all of these variables are now significant. Any variable which just has a dot means that it's now void effectively, because it's being explained by the interaction by age and class. It's not bringing anything new into this model by just having gender alone, but it's very well explained by including the interaction with age and gender and class and gender. And what we mean by this is that older women may not have been more likely to survive because all women were prioritised to get off the ship, but perhaps younger men were more likely to survive than younger women. And again, there may have been differences in class. We can see that we have a significant interaction term here. So for example, it might be that if you were a woman, you were more likely to survive if you were in first class, but perhaps if you were a man, maybe you were no more likely to survive if you were in first class. But if you were a woman in second or third class, perhaps you were more likely to survive than a man in second or third class. So that's why we have a bit of a complicated situation. So I hope this video was useful in helping you to check models for your regression.